The overall goal of this procedure is to deposit spin and spray-coated films of inorganic nanocrystals under ambient conditions to build fully solution-processed solar cell devices after ligand exchange and annealing.
This method can help answer key questions in the fields of nanoscience and applied materials interfaces, such as, can we build functional electronics out of inorganic materials by preparing them on the nanoscale so that we can solution process entire devices from the bottom up? The main advantage to this technique is that we can start thinking about spraying electronics onto new and unconventional surfaces. This includes spraying large and irregular areas in a short time thanks to the additional freedoms of deposition.
Though this method can specifically provide insight into building photovoltaic devices, it can also be applied to other systems, such as spray processing of LEDs, transistors, and capacitors.
When synthesizing the cadmium selenide and cadmium telluride inks, follow the text protocol up to the pyridine synthesis step. Decant the supernatant and add back 5 ml of distilled pyridine and 5 ml of 1-propanol. Then, flush the flask with an inert gas and sonicate the mixture at 40 kHz for 30 minutes. It is also important to filter the ink through a 1-micron PTFE syringe filter and measure the concentration of the ink by desiccating 200 microliters. Finally, dilute the ink with pyridine and 1-propanol as needed and store the ink under